This lesson is on theoretical and experimental probability. There's not going to be a left-hand page for this. It's going to span the 2 pages of your notebook on 182 and 183. So make sure the theoretical probability is first. Theoretical probability, so like a theory, it's how likely an event will happen based on assumptions or guesses about an experiment that hasn't been done yet. That's important. Hasn't been done yet. So the probability of an event is the number of times the event could occur over the total number of possible outcomes. So if we're calculating theoretical probability given one fair item, okay, so this is saying one fair die meaning, it's not weighted, you're not cheating in Vegas or anything to win some extra money. If it's a fair die, that means anything is possible. So the probability of rolling a fair die, remember there are 6 sides on a die. You can land on a 1 through a 6. So the probability of rolling a 6, there's only one chance. So that's the number of times it could occur, only once. If you roll it one time, you only got one chance of making it. Out of a total, there are 6 options. Those are 6 possible outcomes, okay? Now, the decimal version of that, 1/6 as a decimal is 1/6. It repeats, so 167 thousandths. And as a percent, you move the decimal to the right twice, 16.7% chance of rolling a 6. So then the second one says, well, what's the probability of rolling an odd number? Well, I have 1, 2, 3 possible numbers to roll out of the 6 possible outcomes, which reduces, we know, to 1/2. What does that half look like as a decimal? 0.5 or 0.50. And as a percent, there's a 50% chance of rolling an odd number. Well, what about then the probability of rolling a number greater than 4? Well, what numbers are greater than 4? Only 5 or 6. So that's 2 likely number of events that could occur over a total of 6 possible outcomes, because there are 6 sides on that die, which is 1/3. So 0.333 repeating, about 33.3% chance of rolling a number greater than 4. So then let's look at this next section. That's given one fair item. This next one is going to look at 2 fair items. So what if I rolled 2 dice, okay? Here are the possible outcomes. They already did it for you. You didn't even have to do any work for it. Those are all of the possible outcomes for rolling 2 die. So then let's look, what's the possibility of rolling a double? Well, let's see. There's a double. There's 1, 2, 3, 4, 5, and you could also roll, 6 is cut off of all of that, isn't it? That's okay. You know that there's 6-1, 6-2. You can write that in there if you want. 6-1, 6-2. All that got cut off. Sorry. Okay. There are 6 possible outcomes of rolling a double. Out of how many total options or available things could I have rolled? How many combinations? 36. So let's reduce that fraction to 1/6. And we already saw that that decimal is 0.167 or 16.7%. The probability of rolling a sum of 10. So let's see, a sum of 10. That's going to have to be 5 and 5, or 6 and 4, or 4 and 6 could also have been it. So that's 3 possibles out of a total of 36 is 1/12. As a decimal is 0.083 or 8.3%. Not a very high chance of rolling a sum of a 10. The probability of a sum that is less than 5, okay, less than 5, so that's 2, 3, 4, 5, 6, that will be 5, so 6 out of those 36, I hate that I'm using a different color, which is 1/6, and again, we already know that decimal and that percent. Okay, that's theoretical, something that could possibly happen but hasn't yet. You're making those assumptions. All right, so then we're going to look at experimental probability. Okay, experimental probability is how likely an event will happen based on repeating an experiment many times. So the probability of that event, that's what this stands for, the probability of the event is the number of times the event does occur over the total number of trials. So example 1 is after 100 spins, so that's how many times it did happen, it already did, the following information was recorded. So they spun a 1 12 times, a 2 15 times, and so on. So what was the probability of spinning a 5? Well, it actually happened 14 of the possible number of trials was 100, which reduces to 7 over 50, or 0.14. Move the decimal twice, 14%. We have the probability of spinning an even number. So I'm going to add this 15, 13, 13, and 12. 53 out of 100 possible 100 trial spins, which is 0.53 or 53%. And then a number less than 3. So not including 3, 12 and 15 is 27 out of 100. So 0.27 or 27%. Okay? At this rate, how many times should you expect to spin a 2 if you spin it 300 times? Well, what happened with the 2? We saw that it spun 15 times out of the 100 trials, and I want to know how many spins if there were 300 trials. Okay? All you need to do here is that cross multiply and divide thing. 100x equals 15 times 300, which is 4,500, divided by 100. X is 45. Oh, it's already written there. The number of expected spinning of a 2 is 45. And the last thing that we're going to look at is a marble randomly drawn out of a bag and then replaced. The following information was recorded after 50 draws. So let's say that 17 striped marbles were pulled, 15 black marbles were pulled, and 18 white marbles were pulled. Okay? So what was the probability that you drew a striped marble? It happened 17 times. Out of how many times did you draw after 50 times? So 17 over 50 is 0.34 or 34%. a black or a white, so together that total was 33. Out of how many times did you draw? 50. So I have 0.66 or 66 hundredths or 66%. So I want you, this is considered your left-hand page. I want you to try this right here. How many times should you expect to draw a white if you drew 200 times? Go ahead and try to find that fraction, decimal, and percent. The code word for this lesson is notebook.